In today's video, we are going to be talking about the third type of bond, which is the metallic bond. Your topic is metallic bonds, and your goal is I can explain characteristics about metallic bonds. Okay, so some characteristics for metallic bonds. Wait, before you start writing this down, in your digital notebook, if you notice on this second slide, I have this chart for you to write down the different properties. So, if I were you, I would go ahead and pause this video, write down, fill out that chart based off this, and then continue watching this video because there is other notes you need for this section. So this chart, bond formation. Electrons are delocalized among metal atoms. It occurs between two metals. So ionic bonds, the first one we talked about, that was between a metal plus a nonmetal. Then we talked about covalent bonds, which is between two nonmetals. And now we are talking about metallic bonds, which is between two metals. The type of structure is an electron C. They are typically solid at room temperature. They have a very high melting point, which means it has to be very hot for it to melt. They typically don't mix with water. They do conduct electricity. And they can also be malleable, ductile, and lustrous, which means it can be shiny, it can be put into any shape that you are needed, and it can be bent or moved. So now I'm going to break through different terms that we talked about in that chart, but go in a little bit deeper and explain to you what it means. So the type of structure you need to know for metallic bonds is it's an electron C. So ionic bonds gained or lost electrons. Covalent bonds shared electrons. Metallic bonds, their electrons are just kind of everywhere. So it's like when you jump in a pool, you are surrounded by water. Well, that's how the nucleus is in metallic bonds. It's just surrounded by electrons. Conduction of heat. So electrons are able to gain kinetic energy in hotter areas of the metal and are able to quickly transfer it to the other parts of the metal because of the freedom of movement. You need to know that heat causes the electrons to move faster, and the bumping of these electrons with each other and the protons transfers the heat. Okay, so what I want you all to do, if you're at home, go ahead and try it. If you're in the classroom, go ahead and try it. Put your hands together. And I want you to rub them as fast as you can. You notice as you are rubbing your hands together, they are actually getting hotter. Well, that's what's happening with the atoms. Since it's a sea of electrons, they have all this movement. Well, the faster they move together, they're going to warm up, which means they conduct heat very easily. That's also why metal gets super hot in the summer, like that metal piece of your seatbelt that like burns you if you're not too careful. It's because metals conduct heat very easily. Metals also conduct electricity, and that is because the movement of electrons is what causes an electric current. And since metallic bonds have a lot of freedom in their electrons, it causes it to be able to conduct electricity. That's why all your wiring is made out of metals. Malleable and ductile. Metals are malleable and ductile rather than brittle as a result of the non-directional nature of metallic bonds. So they're able to move around very easily, which means they don't break very easily. Which this kind of shows that since it has this sea of electrons, it can just kind of move and be pushed, have force acted on it without breaking those bonds. They also generally have a high melting point because it is a pretty strong bond, so it's not going to break up very easily. They do have a high density because metallic lattices are close packed, which means they will, which affects the density of it. Okay, so here is the definition for metallic bonding. It is a metal is therefore seen as a rigid framework of cations immersed in a sea of electrons that serve as the cement holding the three-dimensional cationic network together. So basically, it's a bunch of electrons holding in the protons or the nucleus together. So that is it for metallic bonds. We were just really wanting to focus on talking about what metallic bonds are and what makes them act like they do. So you need to make sure that you filled out that chart in your digital notebook, and then I will see you in the next video.